Example 4, using eccentricity. In astronomy, the eccentricity of an orbit of Uranus is 0.47. Its orbit around the Sun has a major axis length of 38.36 astronomical units. What is the length of the minor axis of the orbit? Now remember, minor axis is the length from B to B, so this would have a total distance of 2B. This major axis would have the distance 2A. Finally, the eccentricity would be the formula E equals C over A. So what they've given us so far is we know that our E is 0.47, and that's going to equal C over A. We also know that 2A equals 38.36, and so we could solve here for A and find out that A is equal to 19.18, and this is in astronomical units. So now we have A, and we want to find 2B. Well, once we have A, let's plug it in over here. So I could do a little algebra when I plug this in, is I'll multiply by the A, and so I could actually say that 0.47 times A is equal to C, but I know what A is. Let's substitute that. So let me erase this here. I'm going to substitute now right here. And so we'll say that 0.47 times 19.18 will give me my C. So now that we know that, let's go to the calculator. 0.47 times 19.18. This gives us our C, which is 9.0146. So C equals 9.0146. Let me make sure I didn't mess that up. Yep, that's correct. Now we know C and A, and this is also astronomical units. So how do we find B? Well, B is of the formula. It comes from how the foci and the A and B is related. It's C squared equals A squared minus B squared. That's their relationship. So if I take that 9.0146 squared, I can set that equal to my A squared, which is 19.18 squared, and then subtract B squared. That will give us even numbers. So I'm just going to subtract 19.18 squared from both sides, and we're going to see what we get here. That goes away. I know on the right I'll have negative B squared. Let's see what this is on the left. So we come over here, we take this number, we square it, and then I subtract 19.18 squared. That gives me my B, or rather negative B. So negative B is negative 286. Negative 286.609. Run out of space here. I'm going to say 39. And this would be in astronomical units as well. Now the negatives could cancel each other out because it's negative on both sides. And now to get the B and later the 2B, we would take the square root. So B would equal the square root of this number. So now let's go back over here, and we're going to say the square root, square root, and if I just type in this number, it's going to give me an error because you're not allowed to take a negative square root. So I'm going to come up here and just change that to a positive like that. Whoops. Let's try it again. Square root. This time I have it positive. And that's 16 point. We're just going to round this to 16.93. So I'm going to say that B is approximately, so I'll do a little squiggly, 16.93. This is astronomical units. So what is the length of the minor axis? It would be 2 times that. So the last thing I need to do here is I multiply by 2. And I get 38.86. 38.86. 33.86, I'm sorry. So the minor axis is equal 33.86 astronomical units. So Uranus, its elliptical orbit, would have that as the distance between its minor axis. Not the farthest distance this way, that would be this distance, 38.36. It would be talking about this other distance going the opposite direction. Now I have one for you to try.